Hi guys, this talk is about isotopes and average atomic mass. So before we get into that, I want to talk a little bit about the parts of the atom. So remember from previous lessons, we've talked about protons, neutrons, and electrons. Protons and neutrons are the particles that are in the nucleus, and your electrons are outside the nucleus in the electron cloud. Okay, one thing I want to point out is your protons and neutrons have an approximately the same mass of 1 atomic mass unit. And on a lot of textbooks, you're going to see that the electron has 0 atomic mass units. This does not mean that it is actually 0. It is 1 over 1800 of a proton. That's the 1 over 1,800th of a proton. So it is so small that it's negligible. That's why relative to the proton and neutron, the mass is 0. Okay, now the relative charge is also something that's really important. You've got to understand that the proton is +1, electron is -1, and the neutrons are 0. They don't have a charge, they are neutral. Now, the importance of each. The proton tells us the identity of the element. If you change the number of protons, you change the element. The neutron really only determines the mass of the element. If you change the number of neutrons, then you're going to get isotopes. And then the importance of the electron is the reactivity or the behavior of the element, which we're going to get to after Christmas. We're going to spend an entire unit just talking about the electron and how it behaves. So, just kidding. So let's talk about isotopes for just a moment. Isotopes are atoms of an element with a different number of neutrons and therefore a different mass number. They are heavier or lighter than the average mass on the table, depending on the isotope. Something else that's important to note is that every sample of an element has all the isotopes of that element in the proportion they exist naturally. Anytime you have a sample, you have all of its isotopes. Now, each element has a unique number of isotopes, and the only way to really know that is to look it up. Okay, scientists have done a lot of research and they have analyzed the composition of isotopes and the natural abundance percentage of each isotope for all of the elements on the table. An example of this might be hydrogen. Hydrogen has 3 isotopes, for example. So hydrogen's also unique in that the 3 major isotopes of hydrogen have names. Most isotopes do not. We would say hydrogen 1, but hydrogen 1 also is called protium, and it has 1 proton, 1 electron, and 0 neutrons. Okay? Deuterium is the name that we use for hydrogen 2, which has 1 proton, 1 electron, and 1 neutron. So the mass number of hydrogen 2 is 2. And then we've got tritium, which is hydrogen 3, which has 1 proton, 1 electron, and 2 neutrons. Now, question you might be asking yourself is, why are the atomic masses on the periodic table decimal numbers? Well, it has to do with this whole idea of isotopes and their abundances. So for example, if I'm looking at hydrogen 1 is 99.98% of a sample of hydrogen. Hydrogen 2 is 0.0156%. And hydrogen 3 is less than 0.01%. So the idea is, what they do is they take into account the mass and the percentage when they figure out the average atomic mass. So if you looked on the periodic table for hydrogen, the atomic mass listed is 1.008 atomic mass units. Now, this kind of makes sense since 99.98% of the sample has a mass of 1. And so when you look at the average atomic mass, it is much closer to 1 than it is to 2 or 3 because most of your isotope is hydrogen 1. Okay, now there's a mathematical way to figure this out, and we're going to look at that now. Okay, so this is a 3-step problem, and I'm going to show you in order to determine average atomic mass, which is what we're doing. This is calculating average atomic mass. So in order to find average atomic mass, you have to have the weighted average. Sorry, you find the weighted average. So you have to be given two things. You have to be given the mass of the isotope, of all of the isotopes, and their percent abundances. Abundance just means how much there is. Okay, so you have to be given that in the problem. So let's look at the sample of copper. So it says a sample of copper has two isotopes. Copper 63 has a percentage of 69.15%. So it tells us in this example that 63 is our mass number and 69.15 is our percentage. And then it tells us that we have 65, copper 65, with an abundance of 30.85%. So it wants us to use this information to calculate the average atomic mass. So the way that I teach this, there's a quick 3-step method to finding the average atomic mass. The first step is you take each percentage and you divide it by 100 to get a decimal. So my first percentage is 69.15. I'm going to divide that by 100. And my second percentage is 30.85, and I'm going to divide that by 100. So every percentage you have, you divide by 100. So you can do this on your calculator. Or you can realize that when you divide by 100, you're moving the decimal 2 times to the left. Okay, either one works. So once you have done this is step 1. Then you're going to multiply each answer, each decimal, by its mass. So now I have to go back and say, okay, this first percentage has that mass with it. So I'm going to take this times the mass of 63. And this percentage has that mass. So I'm going to multiply this by 65. Okay, and so then when I do that, let me pull up my calculator. So I'm going to take 0.6915 times 63. And so my first answer is 43.5645. And then I'm going to do the second one, 0.3085 times 65. And my second answer is 20.0525. So now so that's step 2, is to multiply your mass of each isotope by that decimal number. And then your third step is you're going to add your answers together. So I'm going to take this plus this. So I'm going to have plus that. So when I added these together, so I took 43.5645 plus 20.0525, and my answer is 63.617 AMU. That's my unit, atomic mass units. Now, if I compare this to the number on the periodic table for copper, copper's number on the periodic table is 63.55. That's from the periodic table. So this one is pretty close. Now, there is a little bit of difference, and some of that has to do with rounding. We used very, very general masses here, when in actuality, you can use a very, very specific mass. So we're going to do that in our next problem. All right, so let's go to the next problem on the next page. All right, so here's another example. We're going to use the same 3 steps to find the answer to this problem. It says calculate the average atomic mass of neon. So when you see calculate average atomic mass, you're going to do these 3 steps. Step 1, divide by 100. Okay, you're going to take your percent and divide it by 100. So I've got 3 isotopes of neon. Neon 20 has an exact mass of this. If it gives you an exact mass, that's what we're going to use. And it tells me my first percentage is 90.48%. So I'm going to divide that by 100. Then my second percentage, neon 21, has an exact mass of this, AMU, and a percentage of 0.27%. So I'm going to divide that by 100. And then my third isotope has an exact mass of 21 and a percentage of 9.25%. So I'm going to divide that by 100. So I'm going to move my decimal 2 times to the left, so 0.9048. Now be careful on this one. If I move it 2 times to the left, I get 0.0027. 2 times to the left is 0.0925. So those are my answers for step 1. So now for step 2, let's see if I can change my color. So for step 2, I'm going to multiply each of these by their masses. So I need to go back. Okay, the mass that goes with this is 19.992440. You might say, Ms. Watson, why do I have to use that big number? Why can't I just use 20? This is going to give you a closer answer, or a better answer that's going to be closer to the answer on the periodic table. 993847 was the second one, and then the next one was 21.993366. All right, so now I'm going to bring my calculator back up, and I'm going to take 0.9048 times 19.992440. And then the second one, I'm going to take 0.0027 times 20.993847. The last one, I'm going to take 0.0925 times 21.993366. Okay, and so now I'm going to add all of these together. So I'm going to say plus, plus, enter. Something happened wrong there. What happened? Oh, I see what happened. Just kidding. All right, so I'm going to go back to this one, and we're going to do 0.0925. Yeah, messed that one up. Times 21 point. It's not recording my decimal place. 993366. That's better. So we're going to take that plus this one, plus all the way back up to my 18. That one. That's better. So it's always good to have a sense of what you should have for your answer. I knew that my answer should be around 20 because I looked on the periodic table for neon, and neon's average atomic mass is around 20. So my answer for this, my average atomic mass, is 20 and we're going to just round to the hundredths place, 20.18 AMU. And so we're going to compare that to the periodic table. So, oh, very, very close. So on the periodic table, we've got 20.1797 is the one that I was looking at, which is very, very close to 20.18 AMU. So that was on the periodic table. Okay, so you can use the periodic table to check yourself. Your average atomic mass should be pretty close to the average atomic mass on the periodic table. But in order for you to get credit when you do practice on this, you have to show me all the steps. You have to show me that you divided by 100, that you've multiplied by each mass, and that you've added them all together to get your average atomic mass. Also, make sure you include atomic mass unit, or AMU, as your unit. Okay, and we'll do more practice with this in class. I hope this was helpful. Thank you guys for joining me.